A V12 engine is a V engine with 12 cylinders mounted on the crankcase in two banks of 6 cylinders, usually but not always at a 60-degree angle to each other, with all 12 pistons driving a common crankshaft. Since each cylinder bank is essentially a straight 6, this configuration has perfect primary and secondary balance no matter which V angle is used and therefore needs no balance shafts. A V12 with two banks of 6 cylinders angled at 60 a degree, 120 a degree or 180 a degree from each other has even firing with power pulses delivered twice as often per revolution as a straight 6. This allows for great refinement in a luxury car. In a racing car, the rotating parts can be made much lighter and thus more responsive, since there is no need to use counterweights on the crankshaft as is needed in a 90-degree V8 and less need for the inertial mass in a flywheel to smooth out the power delivery. In a large displacement, heavy-duty engine, a V12 can run slower than smaller engines, prolonging engine life. Early V12 engines, marine engines. The first V-type engine was built in 1889 by Daimler, to a design by Wilhelm Maybach. By 1903 V8 engines were being produced for motorboat racing by the Socia copyright tar copyright Antoinette to designs by La copyright on Le Vavasseur, building on experience gained with inline 4-cylinder engines. In 1904, the Putney Motor Works completed a new V12 marine racing engine, the first V12 engine produced for any purpose. Known as the A Craig Dar Paragraph Rualda unregistered trademark engine after Putney unregistered trademark S founding partners, the engine mounted pairs of L-head cylinders at a 90-degree included angle on an aluminium crankcase, using the same cylinder pairs that powered the Campania unregistered trademark S standard 2-cylinder car. A single camshaft mounted in the central V operated the valves directly. As in many marine engines, the camshaft could be slid longitudinally to engage a second set of cams, giving valve timing that reversed the engine unregistered trademark S rotation to achieve astern propulsion. Starting as by pumping a charge into each cylinder and switching on the trembler coils. A sliding camshaft gave direct reversing. The camshaft has fluted webs and main bearings in graduated thickness from the largest at the flywheel end. Displacing 1,119.9 qin, the engine weighed 950 pounds and developed 150 bhp. Little is known of the engine's achievements in the 40-foot hull for which it was intended, while a scheme to use the engine to power heavy freight vehicles never came to fruition. One V12 Dar Paragraph Rualda marine engine was found still running in a Hong Kong junk in the late 1960s. Two more V12s appeared in the 1909-10 motorboat racing season. The Lamb Boat and Engine Company of Clinton, Iowa built a 1,558.6 qin engine for the Campania unregistered trademark S 32-foot Lamb 4. It weighed in at 2,114 pounds. No weight is known for the massive 3,463.6 qin F-head engine built by the Orleans Motor Company. Outputs is quoted as a or nearly 400 bhp. By 1914, when Panhard built two 2,356.2 qin engines with 4 valve cylinder heads, the V12 was well established in motorboat racing. Motorcar engines. In October 1913, Louis Coatalm, chief engineer of the Sunbeam Car Company, entered a V12-powered car in the Brooklands short and long handicap races. The engine displaced 9,048 cc's, with bore and stroke of 80x 150 ohm. An aluminium crankcase carried 2 blocks of 3 cylinders along each side, with a 60-degree included angle. The cylinders were of iron, with integral cylinder heads with L-shaped combustion chambers. Inlet and exhaust valves were operated by a central camshaft in the V. Valve clearance was set by grinding the relevant parts, the engine lacking any easy means of adjustment. This pointed to Coatalm unregistered trademark S ultimate aim of using the new V12 as an aero engine, where any adjustment method that could go wrong in flight was to be avoided. As initially built, the V12 was rated at 200 bhp at 2,400 rpms, weighing about 750 pounds. The engine powered the car to several records in 1913 and 1914. Early aero engines. In 1909 Renault pioneered Aero V12s with a 60-degree air-cooled engine with individual fin cylinders and F-head valve arrangement, driven by single camshaft in the crankcase. This was developed to a 12,160 cc's unit which weighed 772 pounds and produced 138 bhp at 1,800 rpms. The propeller was driven from the nose of the camshaft in the central V, rather than from the crankshaft, thus providing an automatic half-speed reduction, improving propeller efficiency. Renault Euro unregistered trademark S designs were closely followed in Britain by the Royal Aircraft Factory. Its RAF4 engine displaced 13,195 cc's, 100x 140 m, produced 140 bhp at 1,800 rpms, for a weight of 637 pounds. Its RAF4 derivative was produced in substantial numbers during the war. By 1912 ABC were offering a water-cooled engine of 17,375 cc's, claimed to produce 170 bhp at 1,400 rpms and weigh 390 pounds Euro 520 pounds with radiator and coolant. In March 1914 Sunbeam exhibited an airborne version of Toodle's VAR Euro unregistered trademark S engine at Olympia. Racing in 1913 had helped to prove the design, and encouraged a 10 m increase in bore to 90 m, the stroke remaining at 150 m. Its rated output was 225 bhp at 2000 rpms. Named the A Hawker Euro unregistered trademark, the engine was the most powerful available to British aviation at the outbreak of WW1. During the war further enlargement to 100x 150 m created the 240 bhp Kirchhoff Euro unregistered trademark. Later V12s in aviation. By the end of World War I, V12s were well established in aviation, powering some of the newest and largest fighters and bombers and being produced by companies such as Renault and Sunbeam. Many Zeppelins had 12-cylinder engines from German manufacturers Maybach and Daimler. Austro-Daimler of the Austro-Hungarian Empire, produced also V12, designed by Ferdinand Porsche, with first 300 and later 345 horsepower, used with the big flying boats of the Naval Air Force. Various U.S. companies produced the Liberty L-12. Soon after the end of WW1 V12 engines powered the first transatlantic crossings by the Curtiss NC flying boats, the first non-stop crossing by Alcock and Brown in a Vickers Vimy. V12 engines reached their apogee during World War II. Fighters and bombers used V12 engines such as the British Rolls-Royce Merlin and Griffon, the Soviet Klymov VK-107 and Mikulin AM-38, the American Allison 51710, or the German Daimler-Benz DB600 series and Junkers Jumo. These engines generated about 1,000 HP at the beginning of the war and above 1,500 HP at their ultimate evolution stage. The German DB605 DC engine reached 2,000 HP with methanol water injection called MW50 equipment. In contrast to most Allied V12s, the engines built in Germany by Daimler-Benz, Junkers Jumo, and Argus were primarily inverted, which had the advantages of lower centers of gravity and improved visibility for single-engine designs. Only the pre-war origin BMW 6 V12 of Germany was an upright engine. The United States had the experimental Continental 41430 inverted V12 engine under development, with a higher power-to-weight ratio than any of the initial versions of the German WW2 inverted V12s, but was never developed to production status, with only 23 examples of the Continental inverted V12 ever being built. The only American-design inverted V12 engine of any type to see even limited service in World War II was the air-cooled Ranger V770, which found use in Stateside-based training aircraft like the Fairchild AT-21 gunner twin-engined advanced trainer. The Rolls-Royce Merlin V12 powered the Hawker Hurricane and Supermarine Spitfire fighters that played a vital role in Britain's victory in the Battle of Britain. The long, narrow configuration of the V12 contributed to good aerodynamics, while its smoothness allowed its use with relatively light and fragile airframes. The Merlin was also used in the Avro Lancaster and de Havilland Mosquito bombers. In the United States, the Packard Motor Company was licensed by Rolls-Royce to produce the Merlin as the Packard V1650 for use in the North American P-51 Mustang. It was also incorporated into some models of the Curtiss P-40, specifically the P-40F and P-40L. Packard Merlins powered Canadian-built Hurricane, Lancaster, and Mosquito aircraft, as well as the UK-built Spitfire Mark 16, which was otherwise the same as the Mark 9 with its British-built Merlin. The Allison V1710 was the only indigenous US-developed V12 liquid-cooled engine to see service during World War II. A sturdy design, it lacked an advanced mechanical supercharger until 1943. Although versions with a turbo supercharger provided excellent performance at high altitude in the Lockheed P-38 Lightning, the turbo supercharger and its ductwork were too bulky to fit into typical single-engine fighters. While a good performer at low altitudes, without adequate supercharging, the Allison's high-altitude performance was lacking. After World War II, V12 engines became generally obsolete in aircraft due to the introduction of turbojet and turboprop engines that had more power for their weight, and fewer complications. V12 road cars. In automobiles, V12 engines have not been common due to their complexity and cost. They are used almost exclusively in expensive sports and luxury cars because of their power, smoother operation and distinctive sound. Prior to World War II, 12-cylinder engines were found in many luxury models, including cars from Packard 1916 to 1923 and again from 1932 to 1939, Daimler 1926 to 1937, Hispano-Suiza 1931, Cadillac 1931, Auburn 1932, Franklin 1932, Lincoln 1932 to 1942, Rolls-Royce 1936, and Pierce Arrow also 1936. Vehicles with 8, 12, and 16 cylinders provide higher levels of refinement compared to those with fewer cylinders, especially important prior to the general adoption of vibration-isolating engine mounts in the 1930s. Packard's 1916 Twin 6 is widely regarded as the first production V12 engine. With a list price of $1,000, the Auburn was the lowest-priced V12 car ever. Production cost savings were achieved by using horizontal valves which, however, did not result in an efficient and powerful combustion chamber. Between 1916 and 1921, there was a vogue of V12s, during which National copied the Packard engine, and Weatherly Motors offered a proprietary engine. Soon after the end of World War I, Lancia offered a 22-degree V12, Fiat had a 60-degree Model 520, British truck manufacturer Ensign announced a V12 that did not materialize, and in 1926, Daimler offered the first of a full range of sleeve valve double sixes, 7,136 cc, 3,744 cc, 5,296 cc and 6,511 cc versions remaining available until 1937. In 1927 more entered the market from Cadillac, Franklin, Hispano-Suiza, Horch, Lagunda, Maybach, Packard, Rolls, Tatra, Voisin, and Walter offering V12 engines. Cadillac and Marmon even developed V16 engines. Improvements in combustion chamber design and piston form enabled lighter V8 engines to surpass the V12 in power starting from the 1930s. Only the smaller, H-Series Lincoln V12 remained after WWII and it was replaced by a V8 in 1949. Similarly, as they seemed excessive for the post-war market in Europe, production of V12-engined cars was very limited until the 1960s. Ferrari has traditionally reserved their top V12 engine for their top-of-the-line luxury sports coupes since 1949. Ferrari's closest rival, Lamborghini has also used the V12 configuration for many of its road cars since the company's inception in 1963. In 1972, Jaguar came out with the XJ12, equipped with a 5.3-liter V12, which continued until the 1996 model year, after which the marque discontinued the 12-cylinder engine. German manufacturer BMW returned to V12 designs for its 7 Series sedan in model year 1986, forcing Mercedes-Benz to follow suit in 1991. While BMW sells far fewer V12 engine 7 Series vehicles than V8 versions, the V12 retains popularity in the US, China, and Russia, as well as maintaining the marque's prestige in the luxury vehicle market segment. The BMW design V12 also appears in Rolls-Royce cars, while the Mercedes engine is also seen in Maybach cars. In their full-size sedans sold in Canada and the USA, Mercedes and BMW have mid-displacement V8s for the entry-level trims, while having the V12 as the flagship vehicle of the brand. For their most expensive Mercedes-Benz nameplates, there are V8-engined AMG models that have comparable power to their biturbo V12-powered cars. However, the V12 trims have a smoother, luxurious ride compared to the AMG V8s, which are sportier and more responsive. The Mercedes S65 AMG, CL65 AMG, and SL65 AMG are all powered by V12 biturbo, making 463 kW and 1000 Nm at 2300 to 4300 RPMs. The 65 AMG cars are faster in a straight line than their 63 AMG equivalents, however the 63 AMG with the performance package posts equivalent acceleration times. The 65 AMG vehicles handle worse due to more weight in the front of the car, however their Custom V12 engine makes them a status symbol. 2. The V12 engine is generally smoother than the other 12-cylinder configuration, the W12. Although the W12 is more compact. 3. In 1997, Toyota equipped their Century limousine with a 5.0 LDOHC V12, making it the first and only Japanese production passenger car so equipped. TVR made and tested a 7.7 L V12 called the Speed 12, but the project was scrapped after the car it was designed for was deemed too powerful for practical use. The only British marques currently using a V12 configuration are Aston Martin Euro, whose Cosworth-developed engine was authorised during the company's ownership by Ford Motor Company Euro, and Rolls-Royce. In 2009, China FAW Group Corporation equipped their Hongqi HQE with a 6.0 LDOHC V12, making it the first and only Chinese production passenger car so equipped. Most production V12 engines in road cars have an even firing order, with the uneven firing exceptions such as Aston Martin 5.9 L V12 and Mercedes-Benz M275 AMG V12s. In 2008, Audi launched their Q7 model with a 5.9-litre V12 twin-turbo diesel engine, making it the first production passenger car so equipped. The engine also appeared in the R8 V12 TDI concept car. Post-war V12 production cars. This is a list of V12 engine production road cars produced since 1945, sorted alphabetically by make. Some tuner companies, such as Brabus, also sell V12 versions of the Mercedes-Benz E-Class and CLS, which were the fastest street-legal sedans upon their respective introductions. Prototypes custom-made with V12 engines. Heavy trucks. Tatra used a 17.6 L air-cooled naturally aspirated V12 diesel engine in many of their trucks. For instance, the Tatra T813 and uses 19 L air-cooled naturally aspirated or turbo V12 diesel engine in Tatra T815. Some large trucks have been fitted with twin V12s that drive a common shaft, although this is often advertised as a V24. GMC produced a large gasoline-burning V12 from 1960 to 1965 for trucks, the Twin 6. It was basically GMC's large-capacity truck 351 V6, doubled, with 4 rocker covers and 4 exhaust manifolds. 56 major parts are interchangeable between the Twin 6 and all other GMC V6 engines to provide greater parts availability and standardization. Its engine displacement was 702 kN, and while power was not too impressive at 250 HP, torque was 585 lb-ft. For fire trucks the rev limiter was increased to produce 299 HP at 3000 rpm and torque was increased to 630 lb-ft at 1600 euro 1900 rpm. It was possibly the last gasoline engine used in heavy trucks in the U.S. Detroit Diesel produced their Series 53, 71, 92, and 149 engines as V12s, among other configurations. Auto racing, V12 engines used to be common in Formula One and endurance racing. From 1965 to 1980, Ferrari, Islake, Honda, BRM, Maserati, Matra, Delahaye, Peugeot, Delage, Alfa Romeo, Lamborghini and Tecno used 12-cylinder engines in Formula One, either V12 or flat 12, but the Ford V8 had a slightly better power-to-weight ratio and less fuel consumption. Thus it was more successful despite being less powerful than the best V12s. The Cosworth DFV also had better aero balance and downforce potential than a V12/flat 12 because it had less frontal area, as it was a tall, narrow engine which also allowed underbody downforce exploitation or ground effect pioneered by Lotus during the late 70s, whereas the V12/flat 12 used by Alfa Romeo and Ferrari was too wide to allow Venturi tunnels underneath their F1 cars, effectively denuding their horsepower and center of gravity advantage they had enjoyed in the mid-70s. Ground effects effectively killed off Ferrari's flat 12 engine and caused Brabham to return to the Cosworth DFV. During the same era, V12 engines were superior to V8s in endurance racing, reduced vibrations giving better reliability. In the 1990s, Renault V10 engines proved their superiority against the Ferrari, Honda and Lamborghini V12s and the Ford V8. The last V12 engine used in Formula One was the Ferrari 044, on the Ferrari 412 T2 cars driven by Gene Ailsey and Gerhard Berger in 1995. In the late 1960s Nissan used a V12 in the Japanese Grand Prix and again in the early 1990s Group C races. At the Paris Motor Show 2006 Peugeot presented a new racing car, as well as a luxury saloon concept car, both called 908 HDIFAP in 908 RC and fitted with a V12 diesel engine producing around or even surpassing 700 PS. This took part in the 24 Hours of Le Mans 2007 race, with a podium finish and very competitive performance, coming in second place after the similarly conceived Audi A10 TDI V12 diesel originally developed for the 2006 season. Large diesel engines. V12 is a common configuration for large diesel engines. Most are available with differing numbers of cylinders in V configuration to offer a range of power ratings. Many diesel locomotives have V12 engines. Examples include the 3200 HP 12-710 from Electromotive Diesel and the 4400 HP GE V012 from GE Transportation. Large V12 engines are also common in ships. For example, WA Currency RTSILA Currency offers V12 engines with various cylinder bore diameters between 26 and 50 cm with power output ranging from 4080 a kilowatt to 14400 a kilowatt. These engines are commonly used especially in cruise ships, which may have up to 6 such main engines. In the past the largest medium-speed diesel engine in the world, WA Currency RTSILA 64 Currency, was also offered in V configuration, and a single 12V64 prototype with an output of 23,280 a kilowatt was produced for an experimental power plant in the late 1990s. Railway V12 diesel engine specs. Railway diesel engines with 12-cylinder developing 500 kW and more, tanks and other AFVs. The V12 is a common configuration for tank and other armored fighting vehicles. Some examples are, German Maybach L120 TRM gasoline engine, used on World War II PZK-PFW3 and PZK-PFW4 tanks. British Rolls-Royce Meteor gasoline engine, derived from the Merlin Aero engine, used on World War II Cromwell and Comet tanks and the post-WWII Centurion and Conqueror tanks. Russian V2 V12 diesel engine, used on World War II T-34, KV-1, KV-2 and IS-2 tanks. Most modern Russian diesel engines for MBTs goes back to V2-based design. American Continental Avenue 1790 engine, produced in gasoline and diesel variants, used on all versions of the Patton tank and on the M103 heavy tank. One of these engines was used to power a hot rod-style car called the Blastoline Special. The 26.6-liter Perkins diesel engine in the Challenger 2 main battle tank and its variants. References. External links, Technical History of the Jaguar V12, Jag Weber.